Welcome to Mrs. Kate's YouTube channel. Tonight we will be reviewing some important information about pollution in the Great Lakes ecosystem. In class, we have been looking at what the Great Lakes were like in 1969. We saw that in general, the lakes were very polluted. The Cuyahoga River was so dirty that it caught on fire. Ducks were choking on pollution in the Detroit River. Algae were growing heavily in Lake Erie. And DDT was entering the food chain and hurting eagle populations. In this lecture, we will be looking to achieve 3 objectives. First, after watching this lecture, you will be able to describe the impact of pollution on the Great Lakes ecosystem. In other words, if pollution is coming into the lakes, what are the effects? Are fish being hurt? Are people being hurt? Second, you will be able to describe how people tried to solve the problems of pollution in the Great Lakes ecosystem. In class, we talked about the Great Lakes Water Quality Agreement and discussed how the governments of the United States and Canada partnered together to improve things. But what exactly did they do? You'll be able to answer this question after watching this lecture. Finally, you will be able to describe the continuing challenges still facing the Great Lakes ecosystem. Even though things are a lot better today, there are still many problems with pollution. After watching this lecture, you will be able to describe what some of these problems still are. As you watch this lecture, please record your notes in your workbook. You will find your guided notes on pages 28 and 29. On these pages, you will fill in the blanks to complete your notes. To make it easier for you, I have highlighted everything you should write in red. If you need to pause the video to finish writing, please do so. Now, in order to understand pollution, it will be helpful to first understand the different types of pollution. We have already discussed these in class. The first type is point source pollution. The second type is non-point source pollution. Let's review what these terms mean. First, point source pollution is pollution that has come from a single place. Really, anything that comes from a single pipe is considered point source pollution. So, for example, chemicals being dumped into the Great Lakes from a water treatment factory would come from a pipe and enter the Great Lakes. This is from a single place, so it is considered point source pollution. Remember, pipe equals point source. The second type of pollution is non-point source pollution. This is pollution that does not come from a single place. Instead, it comes from many places. Air pollution from cars is like this. Think of all those cars driving around on the road, and they are all polluting. In this case, air pollution is coming from many places. In the case of a watershed, there are many ways that pollution can enter an ecosystem. Non-point source pollution can come from housing developments, from city streets, from homes out in the country, from farmland, and even from animal farms. Another source of non-point source pollution is from sediment. Remember, this is the soil that has settled at the bottom of a lake or a river. If that sediment has harmful chemicals in it, it will leak out into the water ecosystem. In this picture, you can see a comparison of these different types of pollutions. Notice how point source pollution is a direct source and is shown coming from a pipe. By comparison, non-point source pollution is an indirect source. Here, water is washing over the ground and carrying pollution with it. Do you see the difference? When water is carried over the ground like this, it is called runoff. This is water from rainfall that is not fully absorbed into the soil. Instead, it flows into lakes or streams. Here's another picture of runoff. You can see how rain is flowing down the hill. It is not absorbed into the ground. Instead, it flows on top of the ground and goes into the lake at the bottom. Here's an even better picture. As you can see, this is one way that water flows through a watershed. It can also carry pollution with it. And here is a final example, another picture of runoff occurring. Sometimes, Runoff has pollutants, or chemicals that pollute the environment. Runoff carries these pollutants into freshwater ecosystems like the Great Lakes. It is important to understand the sources of pollution as we start to think about how to solve the problems of pollution. Which do you think is easier to control? Point source pollution from a single place, or non-point source from many places? Stop and take a few minutes to think about that. I think that point source pollution is easier to control. This is because since it's coming from one place, you only have to deal with that place. When pollution comes from many places, you have to deal with all of those many places in order to solve the problems of pollution. During our next class, you will be reviewing some evidence to determine what the Great Lakes are like today. In your groups, you will review 3 documents that look like this. Each one has a lot of information about pollution in the Great Lakes. Before you begin your classwork, it will be helpful to have some additional information. First, I want us to define the term pollutant. This word refers to any waste that pollutes the water, air, or soil. Pollutants are things like carbon dioxide that come from burning coal at a factory. Another example would be during an oil spill. In this picture, you can see how oil, a pollutant, is entering the ocean ecosystem. When you review your evidence during our next class, you will encounter several different pollutants. Phosphorus is a pollutant that comes from laundry detergent. It is harmful because it causes algae to grow very quickly. We saw that in our article on the Great Lakes in 1969. DDT is another harmful pollutant that we've been reading about. As we've discussed in class, DDT is a toxic chemical that farmers used to use to protect their crops from bugs. When it entered the Great Lakes ecosystem, it went into fish and passed to eagles through the food chain. It was harmful to the eagles' babies because it made their shells too thin. Some other pollutants you will encounter are PCBs, another toxic chemical that is harmful to humans. We'll talk about this one in a minute. Dioxin, another toxic chemical. Runoff from toxic waste dumps. And air pollution from factory smoke and car exhaust. When these pollutants go into the atmosphere, they create acid rain. We'll talk more about acid rain in detail in Chapter 16. In case you are still unsure, I wanted to clarify another vocabulary word, toxic. Toxic means that something is poisonous. It causes harmful effects, such as disease or death. Please make sure you write this definition down in your workbook. As you will see in class, the Great Lakes have been polluted with many toxic chemicals. This is still a problem today. So what happens when toxic chemicals enter our freshwater ecosystems? One example that you will read about in class is about PCBs. PCB stands for polychlorinated biphenyl. Obviously, you will not need to remember all of that. But do know that this is a chemical that was produced by car motors. When PCBs enter the environment, they are toxic, meaning that they're poisonous and harmful to living creatures. They can cause cancer in animals and humans. Luckily, they were banned in the United States in 1979. Dioxin is a very similar type of chemical. You'll read about this one too. So let me show you some examples of what happens when these toxic chemicals enter our freshwater ecosystems. In this picture, you can see the effects of the toxic chemicals. Notice that this little baby bird has a messed up beak. This will make it much harder for him to hunt and eat, and he may not survive into adulthood. This is all because he was exposed to toxic chemicals like PCBs. Here's another picture. This fish has cancer in its mouth. Would you want to eat that? So how does this affect people when there are toxic chemicals in our freshwater ecosystems? Through the food chain, fish absorb these toxic chemicals. When we eat fish with toxic chemicals in them, it causes problems for us. In the 1970s and 1980s, fish in the Great Lakes were shown to cause learning problems and memory loss among the people who ate them. Here you can see a fish advisory for Lake Erie. This chart is advising people on how much fish you can eat. Notice in the key how each symbol is a code for something. A triangle means unlimited consumption. In other words, you can eat as much as you want. A circle means that you can only have one meal per month. Otherwise, you're not going to be safe. A square limits you to 6 times per year. And fish that are coated with a diamond are not safe to eat at all. So you can see here, for example, that the carp and catfish are never safe to eat. They have a diamond symbol. This is because they are contaminated or poisoned with PCBs and dioxins, both of which are toxic chemicals. The Chinook salmon can be eaten in unlimited amounts by the general population, or men in other words, but it should only be eaten once each month by women and children. Now here are some practice problems. Take a few minutes and pause your video to answer these questions. How often can a woman safely eat lake trout? How often can a child safely eat carp or catfish? How often can a man safely eat salmon? Obviously, it's a problem that people can't safely eat the fish in the Great Lakes. No one wants their dinner to give them learning problems or memory loss. So people decided that something had to change. They said, this pollution, it has to stop. As part of the Great Lakes Water Quality Agreement, the government passed laws so that pollution would not continue. Let's look at a few of these laws. In 1969, phosphorus from laundry detergent was a big problem. It was causing lots of algae to grow, and this damaged the ecosystem. So the government passed new laws that placed strict regulations on companies. Soap makers had to stop putting phosphorus in their detergent. Sure, your whites wouldn't be as white, but this was a small price to pay to protect the ecosystem. The effect was that algae levels returned to normal. An added benefit was that mayfly populations also returned to normal. I'll talk about this in a minute. Please make sure you write this down as an effect in the chart in your notes. Here, you can see a satellite image of Lake Erie. Even from space, you can see all of the green algae that's in the lake. But after the new laws, things got a lot better. Algae levels went back to normal. A minute ago, I mentioned mayflies. Here, you can see a picture of mayflies. Here is another picture. Mayflies are small insects that are at the bottom of the food chain, so they are very important. When you have more mayflies, you have more food for fish. Bigger fish means more money for fishermen. Another problem in 1969 was DDT. DDT entered the watershed and passed through the food chain. This caused harm to eagle populations. So the government passed new laws that placed strict regulations on companies. Farmers had to stop using DDT. The effect was that bald eagle populations returned to normal. In this graph, you can see the effect of the law. This graph shows you the number of bald eagle nests in the state of Michigan. Since 1976, the number of nests has increased significantly. This means that more eagles are having babies and more babies are surviving. As we discussed, another problem in the Great Lakes was PCBs. Like DDT, PCBs were entering the watershed, passing through the food chain, and making fish sick. Humans got sick too. So the government passed new laws that placed strict regulations on companies. I'm sure you've noticed a pattern here, that the way to solve all of these problems is to create laws that places strict regulations on companies. so car makers could no longer use PCBs in their motors. The effect was that fish populations returned to normal, and people did not get as sick. Here, you can see how fish populations were returning to normal. This graph shows you the levels of PCBs that were found when fish were tested. Scientists realized the problem in Lake Michigan first, and you can see the significant decrease in PCB levels in the 1970s. But still, as of 2002, the amount of this toxic chemical was not yet zero. There was still some there. So, how does this chart make you feel about eating fish from the Great Lakes? Now let's talk about some of the continuing challenges that are still facing the Great Lakes. One challenge is runoff from toxic waste dumps. When it rains, water washes through our trash. It picks up toxic chemicals and flows into the Great Lakes. This is still a major problem of non-point source pollution, and it is difficult to solve. Another problem is acid rain. Acid rain is caused when chemicals from factories go into the air. When it rains, the rain can cause damage to anything outside. Here you can see a statue that has been worn away by acid rain. This is also an example of non-point source pollution. Another problem is toxic sediment. Toxic sediment is polluted soil that has settled to the bottom of lakes and rivers. The toxic chemicals don't stay in the soil, but they go into the water and affect plants and animals in the ecosystem. Removing such sediment is very difficult and very expensive. What type of pollution do you think this is? Is it coming from a single place, from a pipe, or is it coming from many different places? Are you surprised? The most difficult kinds of pollution are non-point source pollution. These are very, very difficult to clean up. Here is another graph to help us understand the problems of pollution in the Great Lakes. What does this graph show us? As a final thought, I want to ask you this question. What is the best way to deal with pollution? All of this pollution has caused a lot of problems and been very harmful to the ecosystem and to humans. Cleaning it up is expensive and takes a long time. In my opinion, it is better to simply prevent pollution from happening in the first place. To prevent means to keep something from happening. As we continue to discuss pollution throughout this course, I hope you keep this lesson in mind. So that's all for now. Thank you for watching Mrs. Kate's YouTube channel and for doing your homework. This will make your next geography class much easier. If you have questions, please write them down and bring them with you to class.